Hello everyone, my name is Harish and now I'm going to speak about heat treatment of steels. So basically the heat treatment of steels definition is a series of processes involving heating and cooling operation. This is applied to a material to modify the internal structures, changes in physical, mechanical and chemical properties of material. Heat treatment methods are applied in order to strengthen the metals. The temperature and time of heating are strictly controlled as it has effect on grain size. After attaining the desired temperature, the metal is cooled at a specific rate. Stages of heat treatment process. Heating a metal or alloy to define temperature. The temperature is austenitic. Holding the metal at the temperature for a sufficient period to allow necessary changes to occur. Cooling to obtain desired properties. Example ferrite, pearlite, martensite. Various heating sources are air, oil, salt baths. Cooling media. Brine solution, cold water, water plus soluble oil and air. Air is artificial or natural. Objectives, importance of heat treatment process. To relieve the internal stresses, refining the grain size to improve the mechanical properties, improve machinability, harden and strengthen the metal, improve electrical and mechanical properties, improve wear resistance, improve corrosion resistance. Heat treatment is divided into two types, bulk and surface or case hardening. In bulk, it is divided into four types: annealing, hardening, normalizing, tempering. So in annealing, we have full annealing, process annealing, spheroidized annealing, stress relief annealing. And in tempering, we have low temperature, medium temperature, high temperature, and austempering, martempering. Surface or case hardening is divided into two types: diffusion process and thermal process. Diffusion process is divided into four types: carbonizing process, nitriding process, cyaniding, carbonitriding. And thermal process is divided into flame and induction hardening. Case depth. It is known as the depth or the thickness obtained on the specimen after heat treating, called as case depth or case thickness. Surface of the workpiece will be hardened. So now annealing. It is the process of heating the metal to a suitable temperature and slow cooling inside the furnace. As a result of slow cooling, the metal acquires an equilibrium structure which causes the following: to relieve the internal stresses, reduce hardness and improve ductility, and to refine the grain size, and to produce a definite uniform ductile coarse grain microstructure. And the applications of annealing are casting, forging, press works. Of annealing. Full annealing. It is known as hypoeutectoid steels. The steels contain less than 0.7% are heated between 723 degrees Celsius to 910 degrees Celsius. This is done to obtain austenite structure and the temperature is maintained for a period of time. Cooling is done in furnace by decreasing the temperature 10 degrees centigrade to 30 degrees centigrade per hour. The specimen is removed from the furnace and air cooled to the room temperature. Structure of pearlite is obtained which has uniform medium coarse grain size, which is soft and ductile in nature. For hypereutectoid steels, points to be gathered from previous slides. The heat treatment is done between 723 degrees centigrade Celsius to 1138 degrees centigrade. Structure will be coarse pearlite in nature. The objectives of full annealing are: soften the metal, refining crystalline structure, reduce hardness, relieve internal stresses, improve machinability, improve ductility. Process of annealing. Low carbon steels. It is a heat treatment process used to soften and increase the ductility. The metal is heated between 650 degrees Celsius to 750 degrees Celsius. They are held for a period of time to achieve softening. Later they are cooled. This process leads to recrystallization. It leads to improve in ductility, softness, free from internal stress. The above heat treatment results in hardness reduction and increase in percentage of elongation. Sheets and wire manufacturing are the common applications. Stress relief annealing, it is known as alloy steels. It is employed to eliminate the internal residual stresses induced by previously strain hardened metal. Casting, machining, cold working, welding, forging, and rolling. Internal residual stresses are caused due to plastic deformation process, non-uniform cooling of a metal, heating and cooling of alloys made with two different metals having different densities. The effects of internal residual stresses are: if the stresses are not removed, distortion or warpage of material occurs. Now the operation. The alloy steels are heated to 650 degrees Celsius to 750 degrees Celsius, held for a period of time and cooled slowly. This type of treatment is called as recovery, which is the phenomenon that removes internal residual stresses with little change in mechanical properties and no drastic change in microstructure. Speodized annealing. High carbon steels or tool steels. These steels are too hard and difficult to machine. The heat treatment is done between 750 to 800 degrees centigrade and holding the specimen at the same temperature for several hours, 2 to 5 hours, and cooling it inside the furnace. This causes a spheroidal formation, which is centimeter structure which is hard in nature with soft grains. Objectives of spheroidizing. So therefore the objectives of spheroidizing are to soften the hardened steel and to improve ductility, machinability, and formability. To maintain medium hardness, strength, wear resistance. Normalizing. It is a process of heating the metal and cooling the metal in air. Objectives: to refine the grain structure, increase the strength of steel, non-uniform structure when compared to annealing, relieve internal stress, improve machinability and ductility. Now the operation. The steel is heated between 750 to 950 degrees centigrade. It is held at this temperature for short time, for 15 to 30 minutes. It is allowed to cool in air. Due to faster rate of cooling, normalized steel possesses fine grain structure than annealing process. Now the differentiation between annealing and normalizing. In annealing, grain size is coarse when compared to normalizing process because of slow cooling process. But in normalizing, fine grain structure is obtained as the cooling process is faster than annealing. The more expensive process, cost of furnace, temperature sensor, and in normalizing, less expensive process. The process of annealing consumes more time, while the normalizing consumes less time. Annealing process is done at less than 900 degrees centigrade, while the normalizing process is done at more than 900 degrees centigrade. To relieve internal stress and to soften the metal and improve the ductility, and in normalizing, to improve the mechanical properties of metal like strength, toughness. Grain size distribution is more and uniform in annealing, while the grain size and distribution is less and non-uniform in normalizing. In annealing, the hardness obtained is less, while in normalizing, the hardness obtained is more. Hardening. It is a heat treatment process which increases the hardness by quenching. Steel is rapidly cooled from austenizing temperature. After hardening process, the microstructure produced will be martensite in nature. Steel is heated between 725 to 900 degrees centigrade. Is heating process. The heated steel is held at this temperature for a period of time to allow complete austenite formation. It is soaking process. Steel is allowed to cool in a water bath or oil bath to room temperature. It is known as cooling process. So these are known as heat treatment of steels.
Okay.